Aside from frustrating journalists trying to make sense out of their piles of paper, wind is an ever-present variable in aviation for aircraft of all sizes. For generations, mankind has been playing and occasionally catastrophically losing a dangerous game with wind-shifting weather systems every time we take to the skies. Fortunately, now we're increasingly prepared with advanced equipment to keep us from getting blown away. Wind shear, where wind changes in direction or speed over a short distance, can quickly turn a smooth flight into a dangerous one. Given enough elevation, pilots can easily recover, but options are much more limited around takeoff and landing. That's why Russian scientist Mikhail Konevsky has developed technology to provide pilots and air traffic controllers with improved wind shear warning.
The atmosphere around airports is unstable. In some cases, airports have been built in places with complicated landscapes. Take, for example, Hong Kong, where roughly 1 in every 250 landings and takeoffs is performed under hazardous wind shear conditions.
Airports of the future will be fully covered with advanced sensor equipment to map out wind and other hazards, information that will help relieve congestion and increase throughput, a gold mine for the aviation industry. Old-school wind shear detection systems rely on anemometers, or simple wind gauges. The LIDAR Wind Profiler 300, developed by Russian firms Laser Systems and aircraft engineering concern, is ground-based, shooting laser beams skyward and then determining wind direction and speed by detecting the frequency of the backscattered light. At least in principle, one LIDAR Wind Profiler should give more detailed information over shorter distances, crucial around airports and low-flying aircraft, than several anemometers spaced out around the same territory.
The task is actually quite simple. Our device here will now measure the wind profile at an altitude of 300 meters. In the vicinity, you can see a tower with special platforms where wind gauges, like the one I'm holding, are installed. Our goal is to prove that the measurements of our LIDAR wind profiler correspond to the measurements obtained through the sensors installed on this high meteorological tower.
Up against a whole host of spinning anemometers, just one scanning module on the LWP-300 is left to paint an equally accurate picture of the wind over this Kaluga region test site. The stakes are high, since the losing system may soon be consigned to the dustbin of aviation history. The physical benefits of replacing the towers in the already cluttered space around modern airports is obvious. Servicing the ground-based LIDAR systems would also be less of a challenge. But if the numbers don't back up the wind profiling benefits, then the towers are better left in place. Fortunately, the new technology performed perfectly and may soon be ready for full-time action.
The tests have been completed successfully, and most importantly, in the near future, we hope to get certified by the Interstate Aviation Committee, the organization that deals with equipment certification. Once we've got that, our task is to provide this equipment for Russia's first wind shear detection system and install it in Vladivostok, which will be hosting next year's major international summit. We should ensure maximum flight safety for the high-ranking guests and, naturally, all the commercial passengers flying to and from Vladivostok every day.